All right, in this video, we want to derive this function over here, this rational function, and we're going to divide it using the quotient rule because we got a function on the top, we got a function on the bottom, and we're going to use our quotient rule, which is f prime g minus g prime f divided by g squared. So f is simply the top, which is just 4y squared minus 3 to the power of 4 over 3, and g is simply the bottom, which is 8y plus 11 to the power of 1 over 3. F prime, let me derive this. I'm going to bring my exponent down, write the exact same thing inside the bracket, and subtract 1 from my exponent. So my new exponent is 1 over 3. And then because of the chain rule, I'm going to multiply by the derivation of the inside, which is just 8y. This can be simplified. 8y times 4 over 3 is just 32y over 3. Bracket stays exactly the same. Let's derive our g over here. So g prime is just 1 over 3, 8y plus 11. And 1 over 3 minus 1 is negative 2 over 3. And then because of the chain rule, I'll multiply by the derivation of the inside, which is just 8. And this can also be simplified. 8 times 1 over 3 is just 8 over 3. 8y plus 11, the negative 2 over 3. So now let's put all of this in our quotient rule here. I have f prime times g minus g prime times f divided by g squared. So let's write all that down. It's going to be a huge equation. F prime g minus g prime f divided by g squared. Now that I've filled this equation, there are a lot of simplifications that you have to do here. Now keep in mind, you don't have to do this for all calculus courses. It depends on which course you have and how far your prof goes, but I'm going to show you all the possible simplifications, which will technically get you a full solution in any course. The first thing I'm going to do is I noticed that this 3 and this 3 is a common denominator because this 3 applies to this whole thing. This is all one term. This 3 applies to this whole thing. This is one term. So I'm going to move these two 3's down here into the denominator here. And if you're doing this in a test or exam, you can do multiple steps in the same question. I'm just going to show all the steps individually so that no one gets confused trying to understand this question. There are always multiple steps. I would not do all of these steps if I was solving this question in a test. You want to learn to do like 2 steps at a time to make your life easier. I'll also do 1 over 3 times 2 and make the exponent over here 2 over 3. Now, the next thing we notice over here is that you have 8y plus 11, 8y plus 11, 8y plus 11 in all 3 terms. So this has to be simplified somehow. Because we have a negative exponent, the first thing we need to do is get rid of that negative exponents. Technically speaking, negative exponents are not allowed in final solutions. And the simplification over here involved will require to get rid of this negative exponent. So I'm just going to move this to the denominator and make the exponent positive 2 over 3. You can't have a fraction divided by fraction in a simplified solution. So the next thing I'm going to do is make a common denominator for my numerator here. I'm going to multiply the top and bottom over here by 8y plus 11 to the 2 over 3. If I multiply 8y plus 11 to the 1 over 3 times 8y plus 11 to the 2 over 3, I'm just adding the exponents. So my new exponent is just 1. The term on this side here just stays exactly the same. And my common denominator for the numerator is 8y plus 11 to the 2 over 3. And then this is all divided by 3, 8y plus 11, to 2 over 3. Now, in this next step, I'm going to do two different things. Okay, and again, I'm just doing it to save a bit of space and time. But first thing I'll do is I'll combine these two denominators here, because this is the denominator of my numerator, and this is just my denominator. And the denominator and the denominator of the numerator just multiply with each other. So these two terms are multiplying, not dividing. You want to be careful and not cancel these out. They're not cancelable. They're actually multiplying, so we'll add the exponents. The other thing that I'm going to do is I'm going to common factor out an 8 from the top. I'm also going to common factor out 4y squared minus 3 to the 1 over 3. Again, I'm doing these two things in one step to save time and space on your test. So common factor this out of the top. I'm left with 4y bracket 8y plus 11, because this just disappears. And then over here, this 8 just turns into a 1, so I don't need to write that anymore. And if I common factor out 4y minus 3 to the 1 over 3 from this, I'm just subtracting the exponents. 4 over 3 minus 1 over 3 is 1. This is just 4y minus 3. And if I combine my two denominators, it just becomes 3, 8y plus 11. If I add these two exponents, it's just 4 over 3. The last step is just combining all the like terms inside the bracket over here. So I'm going to do that on the side and then just write my final answer to squeeze this in over here. So that's going to be 32y plus 44y, 32y squared, and then here minus 4y plus 3, which is just 32y squared plus 40y plus 3. So this whole bracket just simplifies to this. So my final solution in this question, 8 4y squared minus 3, 1 over 3, and then 32y squared plus 40y plus 3 divided by 3, 8y plus 11 to the power of 4 divided by 3. And that is a fully simplified answer that will give you full marks in any calculus course. If you made it to the end of this video and you found this content helpful, please hit the like and subscribe button and help me get to 1,000 subscribers so I can get my channel monetized. This is video number 525 without making a single dollar, so I would really, really appreciate it if you hit that like and subscribe button. Thank you for watching.